deploy a microservices supporting architecture to PCF. In this section, we will demonstrate provisioning and configuring the config server. We'll also develop an understanding of the config server. Creating and manipulating the discovery server. We'll be constructing the circuit breaker dashboard, and we'll go in depth with our understanding of the hystrix and the circuit breaker pattern. Understanding and provisioning and configuring the config server. In this video, we're going to demonstrate how the config server works. I'm going to help you get an understanding of the application properties and YAML files. We'll understand how to create a JSON object to help configure our config server when we initially deploy it. We'll also be deploying a config server marketplace service using the Cloud Foundry command line interface. So here we are in the Pivotal Web Services console, in our packet demo org, in our development space. And here you can see that I've selected the Services tab, and we have 3 services. And it looks like we want to add a config server. So to do that, rather than creating the config server from here, because what you could do is you could select this config server from the marketplace, select the plan, and then you can actually add parameters here. But you don't want to do that. The way we're going to do this is we're going to create the marketplace service instance. We're going to do it from the command line interface, because one of the things that I found, it's easier to add your configuration when you do it from the command line. So now we're going to create a config server from the command line. Let's go ahead and do that. So here we are in our command line. I've logged into Pivotal Web Services up here above, and you'll see that I've navigated to the packet demo org and the development space. And I have this command here, cf create service -c config server.json. So this is the JSON file that I want to use to configure the config server service. This is the name of the service that I want to configure, the name of the marketplace service. This is the plan, the standard plan, it's free. And this is the name of the actual service. So when I run this command, it's going to create an instance of the config server. Now, you'll notice that, so this config server.json, it's the path to wherever configure.json lives. And because on my machine I've navigated to within the folder where config server.json is, all I have to do is enter this. I don't have to enter the full path, like, a path to config server.json. It's just simply this. So let's go ahead and run this. And it doesn't happen instantly. It does, it takes some time, maybe about 3-4 minutes. It'll take for the config server to spin up. In the meantime, let's go ahead and take a look at some of the client code needed for applications to leverage this config server. So here we are in Eclipse, our IDE, and we're in our customer service application. And this is a RESTful web service application. Now let's run through some of the things that are required for this application to use the config server in PCF. So in our manifest.yaml, as you can see here, we have the config server, the same name that we named it earlier. We have this config server listed under services. That's one of the requirements. The other requirement is in our Gradle, our Maven file, we need to add the config client dependency. It's io.pivotal.spring.cloud, Spring Cloud Services Starter config client. This is the dependency we want when we're using the PCF config server. And also one of the things that will be required is that you have these Maven bombs. So anytime you use one of these Spring Cloud Services Starter dependencies, you're going to want to use this. You also need these Maven bombs in here. You need this thing. And so that's one thing you need. Nope, and that's it. So yeah, so essentially to use the config server, all you really need is this dependency. Now what's going to happen when I spin up this app? Well, here's the thing. If I were to run this app locally on my machine, it would break. Now why would it break? Because it doesn't have permission to access the config server in PCF. So the only way this app is going to work is if I push it to PCF and have it running in PCF. So let's cover the application properties. So here we are. So normally you want to externalize your application properties. So you have your class called app properties, and with some things like, database connection string, some other properties that we'd want to externalize from, keep them outside of the application. So we have these fields annotated with that value. And this path here, as you can see, so shared.properties.course-name, where's this going to come from? So like I said, this application will break from a null pointer exception if it can't manage to get this value from the config server. So we have to have it running in PCF. Now, as you can see, the application properties here I have is empty. Why? Because the idea is that we don't want to keep the application properties in the application itself. We want to keep them in a remote place like GitHub. So let's go ahead and take a look at our application properties in GitHub. So here we are in our Git repo. And so what the config server is a web service that basically proxies our Git repository that has our actual application configuration files. So essentially, when our application hits the config server, it's not really, all of our application properties files are not stored in the config server, they're really stored in our Git repo. The config server just simply proxies it. Let's try to find where that property course, so here we are, shared.properties.coursename. It's in the application.yaml. Now here's the thing, any application, this application.yaml, what's cool about it is that now any application that uses this config repo, by default, will use this application.yaml. This will get shared across any app that uses this config server. So for instance, let's say we wanted to have like a common property that's shared amongst several applications. We could put that in the application.yaml, and there's a reason that we have an application-dev. And just quickly, what application-dev means is, so let's go back to our IDE. You'll see here that this application, when I'm pushing it to PCF, it's going to run in dev. This environment, the Spring profile, gets appended to the application name here. It's appended to here. So now, any application from this config server that has the Spring profile dev will pick up properties from application-dev.yaml. And so in any app named customer-service-1xyz, with the Spring profile dev, we'll pick it from this, and any app named customer-service-1xyz, when any profile, will pick this up. So as you can see, there's this sort of inheritance hierarchy with the config server, and it's just something important to note for now. So let's go ahead and look at our running config server in Cloud Foundry. So as you can see, it's here, and it's up and it's running. Lastly, I want to show you guys what the configuration looks like for the config server. So here we are in our IDE, and in the REST web service application, we'll see that I have these two classes. I have this config server-txt, and this is just simply the command that we use to create the config server. And then there's also this config server.json, and this is the configuration for the config server. And as you can see, one of the configuration items here is the git URL that we want to proxy. So this is the URL to our config repo. So what happens is our application spins up in Cloud Foundry. During the startup of the Spring application context, during the initialization of the Spring application context, before all the beans get bootstrapped, our application will go and try and fetch our application properties from the config server. The config server actually gets those properties from Git. So, and all we really need to provide is the URI here to our config repository. There's other configuration items, like we can drill down to specific folders in there. This in a very simple way, where we have all of our config repos just simply doesn't have a lot of folder structures. You just keep all the properties in the root folder. That's a very simple and easy way to do things, and production as well. And lastly, one last thing you'll notice is that when your application starts up in the Pivotal Cloud Foundry console, when you're tailing the logs, you'll see that you can confirm that your application is fetching its properties externally, because part of the Spring Boot logs is to log the URL and the certain properties files that were used during the startup of the application context. To summarize, the config server relays application configuration from a Git repository to Spring Boot apps over the network. Spring Boot looks for application.properties and application.yaml files in the source main resources folder. We can append our application properties files with the Spring profile or the app name to control which properties files our applications use.